Right, we are live. Hello, everyone. Welcome to this online meetup. We're bringing the Unreal Engine 4 Developers Finland meetup online because of the whole Corona situation, but maybe this is something we could do more often. But I am not on my own, by myself. We have here our fellow co-speakers. Say hi.
Hi.
Hello.
So let's do a brief round of introduction before we start the presentations. So I'm Ari. I am an organizer of the Unreal Engine 4 user group here in Finland, and I'm also a lead programmer at Housemarque. I'm going to be talking about Unreal Engine 4 modules, and because there's not a lot of documentation about it, but it's one of the foundational building blocks of Unreal. So I spent a lot of time and effort making this total everything you need to know guide about Unreal Engine 4 modules, and I hope you like it. How about you, Rob?
My name's Rob. I'm the senior sound designer at Redhill Games, and I'll be joining you today for a talk on the joys of Unreal and using Unreal or prototyping audio design in Unreal, and why that is an important thing to do at the very beginning stages of the project.
Great. How about Elodie?
Hey, so my name is Elodie. I am the co-founder and the CEO of Praxinos, which is a French startup. And so we're doing solutions to bring 2D and 3D animation together. And we started to work with Unreal Engine to make a painting plugin named Iliad. And that's what I'm about to talk.
Great. Thank you very much. So I think we shouldn't wait anymore, and we should just go to the first presentation, and that is Unreal Engine 4 modules. Hi, I'm Ari Arnbjörnsson, and I'm a lead programmer at Housemarque. Before we start, I just want to mention that you can get these slides right now at my website, ari.games. And since we're streaming this talk, you can write any questions you have in the chat, and I'll answer them at the end of the presentation. So for the start, it's good to know what Unreal modules are exactly. A module is just a collection of classes, much like DLLs. And Unreal itself is made out of those modules. For example, Slate is a module, and the new ability system is a module. Quick question, how many modules do you think Unreal ships with? The answer, a little over 1,000 modules. There's a lot of reasons why we should split our code up into modules. First one is that it encourages better code practices and code encapsulation. You'll be more compelled to keep your code isolated when it's in its own module. And when you do that, you can more easily reuse code. Since code is usually quite self-contained in modules, you can use those modules in other projects while not having to worry about it being too tightly integrated with the previous project. Unreal only compiles modules that you use in your project. So if you don't use a module, it won't get included in your shipped product. And because of that, you also get faster compile and linking time, since modules that didn't change don't get compiled again. You can also choose when modules load. So having said all that, let's look into how we can go about creating modules. There are 5 steps you need to do every time you create a module, and to remember them, we can use this acronym, BUILD. The first step is the easiest to remember because it's named the same as the acronym. You need to build your modules. Then you need to be able to use your module, implement it, load it, and depend on it. And we're going to go into each of those steps in detail, starting with building your module. For this presentation, let's say we're creating a module called foobar. The first thing we do is create a new subfolder in our project source folder called the same as our module, and we'll create a new text file in there called foobar.build.cs. This build file will describe how to build your module. It also defines what other modules it depends on. There are more things we can do with it, but those are the main things we'll be using it for. The thing about compiling in Unreal Engine is that all projects are built according to target and build files, not solution files. The Unreal Build tool actually completely ignores all solution files. They're just there for your convenience. To generate those solution files, you can run generate project.bat, right-click your uProject file and click Generate Visual Studio Project Files, or whatever code editor you're using. Or, in the editor, you can also click File and refresh Visual Studio Project. It's a good practice to do that every time you change a build.cs file, or if you move source files around, so you get the most accurate code assist. And this is what the minimum implementation of that build file looks like. You have a C# class named the same as our module that extends module rules. And in the constructor, we define our module's dependencies. In this case, the absolute minimum we need to depend on is Unreal's core module. Core contains the module handling code, so we can't make a module without it. Next, we'll look at how other modules can use our module. For this example, we'll create an enhanced actor that can have a nickname. First, we create two folders, private and public. All headers that other modules should be able to include go into the public folder, while private headers and CPP files go into the private folder. Since we want other modules to be able to manipulate our actor in code, they'll need to be able to include the actor's header file, so we'll put nicknamed actor's header file in the public folder. When working with modules, it's important to know that code from your module is not exposed to other modules by default. You need to mark each function or class explicitly for export. Any headers you don't need or want other modules to include can go into the private folder. Then, there's the primary game module. That's the default module that's created for you when you create a new project. Usually, that module isn't used by other modules, and if you don't plan on exposing anything outside of that module, you can just skip using the private and public folders and put things directly into the source folder. Here's the header file for our example nicknamed actor. It's just a normal actor class with a nickname property and a sayNickname function that might just log out the nickname. This class, as is only exposed to the Unreal editor and the engine. Users can place it in levels and manipulate it via Blueprint. But other modules can't reference it in code, so you can't spawn it from code, cast to it, or call any of its functions. We can add the minimal API class specifier to export minimal type information to other modules. With that, other modules can cast to the class, which allows them to spawn it, extend the class, or even use some limited inline functions. To expose a function for other modules to use, we have to add an export specifier before the function. Unreal creates that specifier automatically for each module in the format of modulename_API, all capital letters. In our case, for our foobar module, that would be foobar_API. Lastly, we can expose the entire class by adding the foobar_API specifier before the class name. That allows other modules to use any public properties or functions of our class. Now we can try to compile our module, but we get an error. Cannot open the include file for actor. Let's look at where the actor header file is located. This part here is the include path, but more importantly in this case, this part is the module it's in. There are two things we need to do to be able to use classes from other modules. First, like we just did, is that we need to include the header file. We need to use the whole path to the header file, starting from the classes or public folder. The classes folder is legacy, by the way. For your projects, always put new classes in the public folder. Then, what we didn't do yet, is to include that headers module as a dependency of your module. And you can find out what any headers module is from its path. It's the name of the folder before classes or public. In our case, that's the engine module. I recommend to use the file path to find out which module a file is in, but it's also listed in the docs. Or you can use other tools like this online classifier where you can just put in the class name and it will tell you which module it's in and what include path to use. That one only works, of course, for engine classes and not your own classes. So let's add engine as a dependency. But now, instead of defining it as a private dependency, we'll add it as a public one. This is needed because if other modules include our nicknamed actor, they'll also get its include for normal actor. Actually, this is a good time to look more at the differences between a private and a public dependency. When you add a child module as either a private or public dependency, it will add include paths to all child modules' public headers. It will also link all of child modules' exposed classes, functions, and variables against your CPP files. So far, no difference between a private and a public dependency. And likewise, a parent module can also add your module as a private or public dependency. The difference between the two methods only becomes apparent in this case. When your module privately depends on a child module, then the parent module will not automatically include the child module's headers or link against its CPP files. In our case, if some module would depend on foobar and our engine dependency was private, parent module would get a compile time error as it would try to include the normal actor header when it includes our nicknamed actor. That's why we should use public dependencies for any external includes in our public headers, so that other modules can include our headers without getting any compile time errors. However, a public dependency will not forward the CPP file linking. Every module must always depend directly on the modules they want to link against. The reason for that is that if you include a header, it will often draw in a huge tree of include dependencies with dozen modules. But when you call a function, you only need to link against that specific object and its parameters. So remember, if only your module's CPP or private header files use a dependency's headers, make it a private dependency. It's preferred as they reduce compile times. Forward declare when you can, so you don't need to mark something as a public dependency. Of course, only when convenient. Forward declaring a class name for a pointer type is easy, for example. I would not forward declare entire function definitions or whole structs, for example. If you ever forget to include a module as a dependency, you'll either get compiler or linking errors. And I want to explain linking errors a bit since I had problems wrapping my head around them when I was starting out. In this example, let's say a parent module wanted to call the sayNickname function on our nicknamed actor, and we get this linker error. That's a lot of text, and it's honestly very intimidating to look at. So let's format it a little bit nicer for our example. I've bolded the 3 important bits in the error. First, we have the CPP file that the error occurred in. In this example, it's in some actor.cpp, but often you'll only get a part of the module cp unity build file. But that's fine since it's not the most important bit. This part is what it couldn't find. So it couldn't find sayNickname in a nicknamed actor. Lastly, and most important for finding where it occurred, this part is in which function it tried to reference it. For this example, I kept nicknamed actor's class as minimal API, but I forgot to export the sayNickname function. That can be very often overlooked when moving code into modules. So remember, unexplained linking errors are almost always because of a missing export specifier or a missing module dependency. Alright, now that we know how to use our module, it's time to implement it. To implement a module, we need to create a new file for it. The convention is to call it the name of the module and then append module.cpp. For our module, we'll call it foobarmodule.cpp. In that file, you need to call the implement module function after any declarations there. And this is just by convention. It could in theory be anywhere in any CPP file in your module. But let's stick to the conventions. What this does is that it exposes your module's main class to the rest of the engine. This is how foobar's file will look like. We start by including module manager, then we call implement module and feed it the class name of the module's main class, and then the module's name without quotes. The module manager header is in the core module, which explains why every single module always needs core as a minimum dependency. This main class is any class that extends iModule interface. So a module main class is basically a class that shares the lifetime of the module itself. It can be anything you want. You can create a custom class yourself, but for most smaller modules that just want to contain some class collection, it can just be an empty class. You can either create an empty class yourself, or more conveniently, you can use an empty class that Unreal already provides for you called fdefaultModule implementation. That implement module line changes a bit depending on what kind of module you're creating. For 99.9% of modules you'll create, it's fine as is. But for game modules, you'll use the implement game module function, and for the primary game module, you'll use the implement primary game module function. That one is usually already created for you when you create a new project. I'll get right back to explaining what game modules are, but first let's talk about what we can use the module's main class for. When you want to create your own module main class, usually implement a couple of functions. Startup module, which is called right after your module's DLL has been loaded and the module object has been created. And shutdown module, which is called before the module is unloaded, right before the module object is destroyed. You can see what other functions you can override in the module interface header. I recommend you check it out. But one great thing about the module's main class is that other code can use it from anywhere. It's basically like a public singleton that is alive as long as your module is loaded. They can simply call load module for your module at any time and call functions directly on it. This is a great power. Use it responsibly. As for module lifetime, during shutdown, modules are destroyed in the reverse order they were created. That means that you can load in other modules during your module start and then be sure that any of those modules will be available in your shutdown module function as well. And let's get back to the concept of gameplay modules. Usually, you only have one gameplay module in your project, your primary gameplay module. You should only mark a module as a gameplay module when it depends on another gameplay module. What that does is that it sets up hot reloading support. Almost any module you create should get used by your primary game module, but not the reverse. So I'd actually be surprised if you ever had to use this. But if you do find yourself in a situation where you'd need a gameplay module, then you can mark a module as one in that module's main class by overadding isGameModule to return true, and then call implementGameModule function instead of implementModule. Take note though that gameplay modules have extra hot reloading overhead, so I'd advise you to avoid making them when possible. But one valid example would be an automation module that tests your gameplay code. Next, we have to load our module. And that's done with module descriptors. Modules need to be described in the game's uProject file, or uPlugin file if you're creating a plugin. You do that to define when the module is loaded and on what targets and platforms. Here's how we would describe our foobar module in our game's uProject file. In the module section, we add this definition which contains the name of our module and its type. The type is used to specify for what targets the module should be loaded. In our case, we want it to be during the game's runtime. That means the module will get loaded in the package game and also in the editor. We can also specify editor here to make it an editor-only module. Runtime and editor are by far the most common types of modules you ever need, but you do have the option of all of these. I won't go through all of them as they're quite self-explanatory, but you can see more info about each of these in the module descriptor header file. The only odd one out here is the developer type. You should not use that anymore as it's deprecated and is replaced by uncooked only. By the way, changing a project's uProject file requires you to restart the editor for the changes to take effect. So if you're creating a new module, there's only one point where you have to restart the editor, and that's when. You also have the option of defining a loading phase if you want. If you don't, it will get set to default, which is usually what you want for simple modules that just contain object types. For more info about each of these, you can, again, look at the enums in the module descriptor header file. They're all commented in details there. And lastly, you can white or blacklist platforms, targets, configurations, and programs where you want your module to load on, or not. Lastly, to get the module to compile, we need to depend on it. Only modules in the dependency chain get compiled. You can add your module to the dependency chain in two ways. First, by having it as a public or private dependency of another module in the chain. This is the preferred method if you don't want your module to be compiled if nothing depends on it. For example, if your game needs the module to work, add it as a dependency in your primary game module's build file. There are cases when no other module depend on it. Then you can add it to the extra module names array in your target CS files. Then it will compile even if no other module depends on it. This is usually a rare case that you shouldn't need to use. Of course, the primary game module goes there, but you might also have some custom editor modules that your game requires. But in that case, I'd argue that a better option would be to put those into its own plugin. Alright, having followed these steps, you should have your working module. This might seem like a lot of steps, but once you get the hang of them, you can start making them quite quickly. Also, no one's really expected to remember all of these, so don't shy away from having this written down or bookmarking these slides to check when making modules. That's what I do. Remember that you can access these slides and this video later at my website, ari.games. But we're not done yet. We can't talk about modules without going into some extra content. You won't be a master of modules until you know about precompiled headers, include what you use, default build settings, module logging, and plugins. Let's start with precompiled headers, or PCHs for short. So, normal header files aren't compiled on their own. They're included and compiled into every CPP file. That's a lot of duplicate compiling, especially if you're including a big header file that includes half of the engine headers. If you're always including the same set of headers, why not compile them only once? That's where precompiled headers come in. You'll create one header file that includes your most commonly included headers. That file will get compiled before any other CPP file in your project. It only compiles once and then gets reused on following compilations. It won't compile again unless any of its included headers change, or any headers they include, and so on. One thing you have to be wary of is that if a precompiled header gets compiled again, all other CPP files in the module need to be compiled again. So it's best to only include engine headers or very rarely changing code in it. There are a couple of types of precompiled headers. The first type is a private precompiled header. It's a custom PCH that you create yourself for your module. You define it in your build.cs file using the private PCH header file property. You feed it the name of your private file, and by convention, it should be named your module name private pch.h. So in our case, it would be called foobar private pch.h. You should never include it yourself in your header and CPP files. Unreal Build Tool will automatically inject it for all compiled files in your module. Also, precompiled headers should only be considered an optimization layer. Don't treat it as an easy include all. You still need to include every header that you actually use. And your code should also compile completely fine even if precompiled headers are turned off. The other kind are shared precompiled headers. Instead of defining your own PCH, you can use a shared one. A shared PCH is when a module defines a precompiled header that only other depending modules can use. The module itself can't use it. They exist in some foundational, often used Unreal Engine modules. Actually, Unreal Ed, Engine, Slate, Core UObject, and Core to be specific. Those are the only ones that exist, and those are the only ones that can exist for now, as only Engine modules can create shared PCHs. The best thing about shared precompiled headers is that they only get compiled once, even if multiple modules use it. You can't choose which one to use. Unreal Engine will choose for you based on a priority score from one of your module dependencies. That priority score is sorted per module by how many other modules with a shared PCH it depends on. It's a bit of a weird explanation, but the module list above is already sorted by that priority. So for example, if your module depends on all 5 of those modules, Unreal will pick Unreal Ed's shared PCH to use for your module when compiling it. So when do you use which precompiled header type? You actually have 3 options. You can create your own private precompiled header. This is good for modules with very big code bases, which is often the case with the primary game module on bigger games. You have to decide what to put in that PCH and how to balance it yourself. You can use a shared engine PCH, which is a good option for every other smaller module. And lastly, you can just not use any PCH. It's not really practical, and I don't know a single reason why you would do it unless you're doing some extreme compile debugging, but you have the option. So let's see where you configure those PCH build settings. It's set in the module's build.cs file. There are 2 relevant settings to configure it: PCH usage property, which takes a PCH usage mode enum, and optionally private PCH header file property when you want to use a private PCH, which is just a string path to the header. So, setting the PCH usage mode. Which settings should we use? Well, it's a bit simpler than enum makes it look, because these 3 are legacy, and you should always choose use explicit or shared PCHs. That option uses a shared PCH by default, or a private PCH if you've set one via the private PCH header file property. It's actually already the default setting from 4.24.2 onwards. So if you're using a project that was created on that version or newer, then you don't even have to set this. The setting will probably get phased out in the future. Next, let's look at include what you use, often acronym to IWYU. It's a simple philosophy where, you guessed it, you only include what you actually use. It just means that your code files should only include their required dependencies. When you turn on Include What You Use mode, then Unreal will warn you if you include one of its monolithic headers. Those are huge headers like engine.h and unreal.ed.h, which just contain a lot of engine includes that were supposed to be convenient, but nowadays they just slow compilation down. They've been marked as legacy headers, so you should stop using them altogether. With Include What You Use mode turned on, Unreal will also warn you if your CPP files don't include their matching header file first. The reason they introduced that convention is because older code always used to manually include the private PCH as the first include in CPP files. This convention allows us to catch that during compile time. Like we mentioned before, what we're supposed to do instead is to define the private PCH with the private PCH header file property in your build.cs file. And lastly, your CPP file should compile just fine without PCHs and in non-Unity builds. And in case you don't know what Unity builds are, it's when Unreal concatenates many CPP files from a single module into bundles for more efficient compiling. They can sometimes hide missing include errors since many files in a module basically get built together. Using Include What You Use has been optional up to 4.23, but it was off by default. If you have a project that was created before that version, you can turn on Include What You Use by setting the PCH mode property to use explicit or shared PCHs in your build.cs file. However, since 4.24.2, it has been set to enabled by default. It's set to default because the default build settings property of a project's build.cs file now defaults to version 2 in new projects. These new default build settings also affect other settings in your project. So let's talk a little bit about those. If you're on a project that was created before 4.24.2, you can upgrade it by setting default build settings to version 2 in your target.cs or build.cs file. What that does is that it sets PCH usage to use explicit or shared PCHs, which enables Include What You Use style build settings. It also sets B legacy public include paths to false. When that happens, Unreal Build Tool omits subfolders from public include paths to reduce compiler command line length and improve compile times. But because of that, you now have to have every include path correct, where before you could have just included actor.h, now you have to include gameframework/actor.h. And this can actually be a huge refactor for big projects, depending on how lazy you've been keeping your include paths correct. Luckily, Epic has a tool to help with the migration. You can use Unreal Automation Tool's rebase public include paths command line tool to fix incorrect include paths. It tries a best guess approach, which should get the majority of includes fixed, but you'll probably have to clean up a few stragglers. Search for that tool in the source code to see how to use it. And lastly, it sets shadow variable warning level to error. What that does is that it treats shadow variable warnings as errors. That basically means that you can't define a variable if a same named one already exists in an outer scope. Now, it's a good practice to have your module use its own log category for easier filtering and also just knowing where log files are coming from. First, you have to declare the log category type. You do that with the declare log category extern macro, which takes in the log category name, its default verbosity, and its compile time verbosity. Log category names for modules are always named log and then your module name. So in our case, it would be log foobar. The default verbosity is what verbosity it starts at when the engine is launched. Display means it shows in the output log window in the editor and gets saved to the log file. And putting compile time verbosity to all means that we can switch between all the verbosities after the game or editor has been launched. If you have some very verbose logging that is computationally intensive, you can filter the code out by decreasing the compile time verbosity, but that also means that you can't switch to that verbosity after the game has launched as it doesn't exist at that time. Then, for example, when debugging, you can just manually change the declaration to include more verbose levels. You can see more info about each verbosity level in the log verbosity header file. So calling that macro will declare a category class that extends flog category. Since it's a whole class declaration, it's most practical to put it into its own header file. Then you can just include it where you plan on logging something. And if you have a private precompiled header, it would also make sense to include that header in there. After declaring the log category, we have to initialize it with our module. You do that by calling the define log category macro with your log category name. What this does is that it instantiates an instance of that log category class, which registers itself with the log suppression system in the constructor. We want this log category instance to have the same lifetime as our module, so you should put it in the same place where you called implement module in the foobar modules CPP file. And lastly, we use the log category. To do that, you use the UE log macro and you give it the log category name, log foobar in our case, a verbosity like display, which in our case wouldn't get filtered out since it's our default verbosity, and finally a normal string with our text. Notice that you can't use Unreal strings with the log macro. And lastly, I'm just going to super briefly mention plugins. They're basically just a collection of modules which you can turn on or off for a project. You can find a blank example plugin in the engine source code in the blank plugin folder ready for you to fill out. And you can also select new plugin from the editor, which has many common starting points for different types of plugins. I recommend checking them out. Alright, that's the end of the presentation. So let's quickly recap. We create a build CS file that builds the module. We expose functions and classes via macros to use in engine or other modules. We call implement module in module name module.cpp. We set when the module loads in the uproject or uplugin file, and we add it as a dependency of another module or target so it gets compiled. I'll now be switching to answering questions, and remember that you can get these slides right now at ari.games, and I'll also upload this video there after this. Also, feel free to reach out to me. My online handle is Flassari, like there in the lower right corner, and you can find me online on most social media sites like Twitter and LinkedIn. Thank you. All right. Thank you, everyone. So I got one question in the chat, which is, Ari, how long have you been working with Unreal Engine 4? And it's actually only been about 2 years. Yeah. Oh, I'm getting clap in the chat. Thank you. So yeah, 2 years with Unreal Engine 4. I've been doing game industry stuff for over a decade. So it wasn't like too much of a transformation. And so yeah, I had to really dive into the deep end when I was taking on the lead role at Housemarque. Can you comment on UE4 modules versus plugins? Yes. Okay. So modules versus plugins. Like I said there in one of the last slides, is that plugins are basically just a collection of modules. A plugin is like one descriptor file called the U plugin, where it describes what modules it has. It's very similar to a U project file. And in it you put a collection of modules you can like activate and deactivate with the plugin itself. But plugins also allow you to have content. So you can have a folder that allows you to have U assets. And that's basically the difference. A plugin just contains modules. And I can wait a little bit more while people are coming up with more questions in their head. Feel free to put them in the chat. I came up with my 2 own questions while we wait for more people to ask if they have anything else. And one was that I got once when I was having this presentation at work, and I got asked, is there any reason you should not use modules? And that's actually a really good question. Like, when would be a case where you shouldn't do it? And one of them is if you can't isolate it enough into its own unit, because there's this overhead that comes with exposing every single function or class. And also, if you have your modules too small, maybe too modular, there's a tiny bit of overhead that comes with loading every single DLL. But usually in the final game you make it in a monolithic build anyways, where everything is just in one giant executable. So in that case, it doesn't matter. But otherwise, I see nothing but pros to using modules if you can isolate it enough into its own module. And I guess I can bring one more of my own questions. As, how big should your game be before switching from a shared precompiled header to a private one? And usually for all small projects, you're fine with just a shared precompiled header. Like you don't even have to set it up. Just make the engine do it all for you. If you're thinking, should I go with a private PCH? It's usually quite quick to just put them together yourself. You can, I think in private precompiled headers, you may actually include the monolithic headers. So you can just get like half the engine from there. And or even you can include, maybe you can even include a shared precompiled header from another. Yeah, that might work. From another module. But it's really easy to test because you just build and you see if it's faster or not. So I would say if you have a huge enough code base that compiling is becoming a really slow thing, then check out making a private precompiled header. If it makes it faster, great. If it doesn't, just don't use it. Okay, one more question on chat. How does primary game module and other gameplay modules interact with each other? Should the other gameplay modules include the primary, or the primary game module should include the small gameplay modules? Excellent question. In my opinion, the primary game module should never be included by other modules. That should only be a very specific scenario. Like for example, if you have editor tools, sometimes you would want them to work on the classes in the primary game module. And in that case, yeah, you can include it. Or if you're doing unit tests. But that's basically it. Otherwise, your include dependencies should always be like a tree, and it should always be one way. So the primary game module should be at the bottom, and it should include everything else, but nothing should go in circles or back to the primary game module. Okay, that's it for the questions. Remember though, and I can't stress this enough, I welcome any questions through like Twitter or email. You can email me. My email is just ari@housemarque.com. It's just my name and the company name. And if you have any questions, go ahead and send them to me. I will happily answer them. And I've said this at every meetup where I had this presentation, and I've never gotten a question, so be the first one. And okay, it's time for the second presentation by Rob, called Joys of Unreal in short. Enjoy.
Good evening, ladies and gentlemen. My name is Rob Carr, and I'm currently the Senior Sound Designer at Redhill Games. And this evening I'm going to do you a talk on the joys of Unreal, audio design prototyping, the importance of audio design during the prototyping stage of development, and why you should let them do it. Now, this is a bit of a sort of a strange subject to sort of talk about because most people don't care about audio, which is unfortunate, but it's very, very true. So first things first, there are two parts to this talk that we're going to talk about. Part one is defining what a prototype is and why audio should be used. And part two is future-proofing your audio while everything is on fire. Now that's an important one because audio is usually the last thing that's going to be used, and it's usually the bit that everybody sort of worries about quite a lot. What happens when people find out you work in the games industry? So a little bit of a sort of a bit of a backstory on this one is whenever people find out I work in the games industry, I have a certain amount of reactions that people give to me. I've been in the games industry now for 15 years. I've spent a significant amount of time of that in Rockstar Games, and I was working freelance. I did some work down at Pinewood Studios and a couple of years at Wargaming Brno over in the Czech Republic. And now I'm here in Helsinki. And almost every single time that I sort of find myself in the games industry and people, or I speak to people about it, they say, oh, it must be nice to be sitting on your ass all day playing games. Or, the problem with insert game that you've had some dealings with, followed by, oh, here's how it should play, like as if we didn't already think of that. And X should be and Y needs to be, and that's how you fix it, because gamers are obviously game designers, and they can clearly fix the problem with our game just because they play lots of games. And my personal favorite one, oh cool, I have this great idea for a video game, which, yeah, pretty much triggers me every single time that I hear it. Really, please tell me more. No, please don't. Okay, that was quite harsh. The only reason most of us react like this is because normal people have no idea what goes into making video games. If they did, they wouldn't ask. But it does beg the question, what does go into making a video game? Now, before a game is made, we need to work out if it's actually a good idea. Chances are it's probably not. And that's okay, surprisingly. Like most people that I speak to in the games industry or any sort of entertainment industry, when they have a good idea, usually it's it's a bad idea. It needs iteration and it needs to be worked on further. But to find out if the idea of the game that we have is a good idea, we need to prototype it. So part 1 is defining a prototype and why audio should be added even at this stage. Okay, so I'm going to look at a few definitions on what a prototyping is. So what is a prototype? A prototype there's several different things that could be a prototype. There is a proof of principle prototype, which serves to verify some key functional aspects of the intended design, but usually does not have all the functionality of the final product. There is a working prototype, which represents all or nearly all of the functionality of the final product. There is the visual prototype, which represents the size and appearance, but not the functionality of the intended design. There's the user experience prototype, represents enough of the appearance and the function of the product that it can be used for user research. A functional prototype, which captures both functionality and the appearance of the intended design, though it may be created with different techniques and even different scale to the final design. And a paper prototype. This is a printed by hand or hand-drawn representation of the user interface of a software product. Such prototypes are commonly used for early testing of a software design. And we have also what's called a vertical slice. Now, a small note about vertical slices. A vertical slice is a portion of a game which acts as a proof of concept for stakeholders before they agree to fund the rest. It is not the same as a prototype in that it is expected to look like the final quality and play like the final game. Some people even release these as demos. It is not a prototype. This is a vertical slice, is like this is how the game will be, or is as close to that mark as we can get. But what does all of this have to do with audio? Which is a really good question. Not a lot. So why is audio really important at the prototype stages? Well, let's flick back to the different types of audio prototypes. So we've got all this big list, and we're going to get rid of the ones that we don't really need to worry about with specifically video games and specifically with audio. So we don't need the proof of principle prototype, we don't need visual prototype, and we don't need a paper prototype. These are all ones that we don't really care about, or as a game, game developer, we don't have to do these sort of things. We will work at this stage. I'm going to highlight the working prototype, which represents all or nearly all of the functionality of the final product. And I'm going to go on to the user experience prototype, which represents enough of the appearance and functionality. And the final productive, functional prototype. But can we now please talk about audio? Because that's why a lot of you are sort of watching this, is because you're interested in the audio side of things. So yes, but a few things you should know. Many studios either don't bother with sound in the prototypes, and it shows, or even worse, they get someone who knows nothing about audio to add sounds they found online to the project. There are so many problems and reasons why this should not be done this way. I'm not even going to entertain it with something that resembles, rationality and no, just don't do that. Bring in an audio professional, and this is going to be the main reasons why you should do that. But why bother at all? So firstly, sound can suppress or enhance the visual perception. And one of the visual prototypes one of the prototypes is of visual perception. Sound can be used to enhance gameplay mechanics. So it can be used as a functional aspect of the game. It can be used to influence the player. Now that is a big one for sound designers because they like we can use sound to generate and identify direction of tone. And that is important to us, I think. Sound can add context to your game. Context is king. I will never say that enough times. People that have seen previous talks that I've done will remember some of the videos that I've done, and it makes a massive difference. So, visual perception. How many times can you see the circle flash? In the comments, feel free to ask. Now watch it without the sound. How many of you said 2 and how many of you said just 1? Now it's not a big deal and it's not a brilliant example, but it highlights very, very quickly how we can make you perceive something in a very different way just by adding a simple sound. This is the most basic way of presenting this information. You can be a lot more complicated with it and you can be a lot more sophisticated with it, but this is a really easy way of doing it. Now, enhancing gameplay mechanics. I'm going to play you some songs here. Well, sounds. So that is a positive thing. And that is a negative thing. So one of them is it's something that's good and it's happy, and the other one isn't. It's a bad thing, it's negative. That enhances the gameplay mechanics. Now, influencing the player. Now I'm going to play you a sound now, and I want you all to listen to it very, very carefully. Headphones would be best for this, so if you have headphones, by all means put them on and have a listen to it. If you wish, close your eyes. Influenced much? It's a very good example of how you can make something sound very influential very, very quickly. I am sorry for that. That was a bit of a poor move on my part, but you get the idea. You get the hint of how we can influence people just on how you hear something. Context. This is paramount. Now you're going to hear something or you're going to see something, and I want you to tell me in the comments what you hear. We hear lots of different sounds every day, and some sounds we hear so frequently we often take them for granted. Good old-fashioned shower. Now this is very typical weather for England, and I'm reliably informed for Helsinki as well in certain times of the year. So if you're curious about Helsinki or England, this is what you're missing. We associate lots of different things unconsciously when we hear sounds, and more often than not, we trust that what we hear is accurate. Sometimes what we hear and what we see are not normally what they seem. Everything that you've just heard is actually bacon frying. It wasn't rain, it wasn't water, it was bacon frying. When we remove context from something, then it changes how we see it. This is really, really important for many, many reasons. The main reason why it's important is because we can change how you see something based on how you hear it. Now, I'm going to refer back to this bacon later on. So there's a method in my madness behind showing you this as a contextualized sort of item. But this is a really good example of how the context is really, really important. You know, you can take anything out of context and use it for something else. But what about video games? We now know what we need. We now know that we need audio in a prototype, but why do we need it at the very beginning? Creating audio in an instructional and an informative way is time consuming. You can't spend 6 months on a prototype and then expect audio to be added in the week at the end and expect that to be the same quality as the rest of the prototype. Implementing audio is based upon iteration, and like everything, the more iterations we have, the more polished it can be. And audio is just as complicated and technical as adding in an art asset or an animation to a game. Part 2. Future-proofing your audio while everything is on fire. That's fine. Now, with audio, over the last 15 years of me actually doing this, I have found myself in a position where this actually is fine. Like, most of my work I can't do until everybody else has finished doing theirs. You know, like the balancing of the guns and like all sorts of different aspects of game design I can't do anything with because my audio is based on exactly on the final product. You know, animations are a really good example of this. You know, it's like I cannot go in and tag the animations for Foley until we have those final animations. There's no point in even trying it. So I can't do that until right at the end when the animations drop. And likewise with many other people, like they can't do the animations until the story's been locked down and the movement and the motion capture's been done. So there's a chain there. But that's not to say that's not to say we can't do anything. In game design, change is not just often, it's essential. Audio can only base its workflow on the design documents that they have to begin with. And almost every single design document that I've had any dealings with is very quickly out of date because it changes very, very quickly. Almost everything that I do from an audio perspective is speculative until we go into full lockdown. The bigger picture is essential because everything will change repeatedly. But that's not to say that it's wasted work. It's not wasted work if you're smart with how you future-proof your work. Everything that I do when I do audio design for a project, if I am brought in at the very beginning of the project, it allows me to build systems of which I can use in a very effective and very confident way in the future. Sure, there is a lot of shaky ground that I'm sort of dealing with here. However, the bare bones and the infrastructure and the architecture behind it is there. You know, the foundations are there, and it's going to make life easier later. So remember the bacon? Well, this is what the bacon looks like in a spectrograph. No other reason for me to show you what this looks like as a spectrograph other than it makes my talk a bit more corporate by adding in a chart in there. And how many times are you going to see the word bacon and chart used in the same time, especially in the games industry? So have a laugh. Seriously though, remember the bacon. Now, the bacon frying I've now cut into a single loop of about 5 seconds, and I've added it into a software that we sound designers use quite frequently called Wise. It is an authoring software, it is middleware, and it's pretty much the go-to sort of middleware that most audio designers will use when it comes down to the authoring of sounds and the implementation of sounds. It is my go-to thing, but not everybody uses it. You know, there are other middleware software solutions out there, but I've been using Wise for years now, and we use it in conjunction with the Unreal Engine. Now, Wise allows us to combine and randomize filters around certain things, so we can change how sounds sort of, we can change how it sounds, we can change the filtering of it, and we can add in distance parameters, and we can adjust all sorts of different things with every single sound that we have. And we can do this with everything from ambience to vehicles to dialogue to movement, sounds, weapons, absolutely everything all goes through Wise, and we have exactly the same parameters that are open to us. So let's look at creating and adding an ambience to a game world. Now, this is going to be fairly technical. This is where the Unreal side of things comes in, which I'm sure you're all sort of eager to see. Once we've sourced all the audio that we need, we can add it to our middleware and we can author it. Once we've got that once we've got those sounds and we've got them sounding and behaving in a way that we want to in Wise, we can look at getting them in the game. So in this particular case, I'm going to look at birdsong. So I have, as you can see, I have 7 different birdsong sparrows tweeting, and they are stuck in a random container. This random container here is very broad, sort of broad speaking. So each one of those will have a randomized volume and a random pitch, so it's never the same twice. It plays in a different order, slightly different pitch, slightly different volumes, and this is what it sounds like. This is based on a fire and forget sound. So although this is one long sort of sound file that I've added in of all of them playing, each individual tweet is actually just one sound that the game will fire, it will play, and then it completely forgets that it's played it. So that's saving up on memory, so I don't have to have like a long loop of the ambience sort of stuff, because in video games we don't know where the player is going to go. We don't know how long they're going to stay there. And if you're doing a demo or you're doing a prototype and there's going to be a lot of people hanging around doing nothing while there's lots of talking going on to the stakeholders or the press or whoever, then you need it to sound not annoying, because annoying things tend to make people not want to spend any significant amount of time with them. Now it's time to get technical. In this particular example, I'm using the Unreal Engine 4, and I'm using the Open World Demo Collection, which is free from the Unreal Store, from the Epic Store. And it's gorgeous. I would highly recommend it. It's really good to look at if you want to have a look at photogrammetry and just generally get yourself around the sort of, using Unreal assets. First, we need to load the audio banks. So we're going to look at the ambience for this game world that we've just downloaded. Now, in Unreal terms, we have to load in an audio bank. Think of an audio bank as a suitcase full of music. So if we don't have the suitcase full of music, then we don't know, full of sounds, and we don't know what sounds we're going to need. So that's what an audio bank is. In this screen grab here, beautifully presented, I've added a box around the area that I want to populate with audio, and I've called it an ambient zone. Now, this particular zone is anything inside of this area is what I'm going to populate with the sounds. Now, remember the fire and forget sounds that we had there? Now, the fire and forget sounds are just going to be placed randomly inside that box. So we're going to go into Unreal, we're going to go into a blueprint, we're going to create what's called, what I call an ambient blueprint, or an audio blueprint for the ambient system. Now, this is a blueprint that you can click and drag into any game level that you're working on. And what it's going to do is, this is just for ambience. So everything that we're going to talk about is all about the ambience. So we're going to get a random location in that ambient zone. So the ambient zone that we were looking at, the box around the game area, we're going to pick a random location inside of that. Now, to do that, we have this wonderful bit of math spaghetti. And what this is basically doing is, this is effectively this calculation here that we're looking at is basically we're going to get a random location inside that box. And once we've got that random location, we can then set the location of where the sound is going to play, and then we can play that sound. And once we've got that, we can do that with different sounds. So in this particular example, I use sparrows and I use woodpecker and forest birds, but you can use any kind of sound that you want to play in a random area. So this is really good for bird calls. It's good for car horns if you're in a city, sort of a city block kind of thing. And there is a really good example of when you use this with crickets and different sort of aspects of how you can use this. So this is just a fire and forget sound. Again, you can add in logic on top of that later if you want to. So, at this stage, we're just prototyping. It's just easier for us to say, right, this game world now has an ambience. So let's look at the wind in a little bit more detail, because an ambient place, wind is a very ambient thing and it adds a lot of character to places. So when we add in the bird song and the different sort of animal sounds that we have, like crickets and things like that, and we add wind into the equation, then we can be a bit more technical, and we can add a layer of depth to the game world without being particularly very, we don't have to be too technical, we just have to be smart. So the wind, for an example, in this particular example, this just randomly plays the wind. In this example, the wind is not in the 3D space. The wind does not play at a random location. It is a 2D sound, and it plays across the whole map. There is no occlusion that's been attached to it. So if you are inside or outside, the wind will stay the same. You can go in and add in a separate parameter to the wind that you can control whether you're indoors or outdoors. But at this stage, we're just going to assume that we are always outside. There is no interior that we're looking at, because the example that I'm giving has no interior. So how can we mess around with this? Well, the first thing that we can do is we can change the wind based on the wind strength. So the game itself might actually have a wind strength parameter, because there might be things like smoke effects that the wind can carry. There might be trees in there that are affected by the wind strength. There might be, if it's a sniper game that you're playing, the wind might be able to affect where the bullet, projectile goes. Many, many reasons why you might have a wind strength parameter in there. This might just be an arbitrary number which you can sort of randomly sort of calculate. In this particular example, this is a metric that was already in the example that I was looking at, so I simply hooked into that, and I use what's called an RTPC, which is a real-time control parameter. But you'll also notice on the right-hand side that we have a player game world elevation. Now what I'm doing there is I'm getting the actor of the player, and I'm asking Unreal in the blueprint, what is the Z-axis? How high is the player, based on 0 being ground zero? And anything in the plus side means that the player is higher, and anything in minus means that the player is lower. Why would we want to do this? Now, the easiest way to sort of answer that is the higher a player is, the more windier it should sound, or the wind should sound different if you are at the high peak than if you're at ground zero. And likewise, if you're in a basement or a low cave area, then that should sound different as well. So just to reiterate, with the real-time control parameter, this is something that is in most of the audio middleware, which is your in-game parameters changing. So effectively what this can do is we can change things. Imagine an RTPC being a light switch with a dimmer attached to it. So imagine 0 as being the light is off, and 100 being the light is fully bright, and the RTPC is effectively the dial. So that's the easiest way to look at an RTPC, and the game, we can use any sort of metrics that we want to drive any of those RTPCs, and we can have as many of those on any one audio aspect that we want. They're controlled via the game. We just have to know how to use them to make them sort of work. In this particular example, we're assuming that ground level is 0, and the highest point and the plus side of this is going to be the highest point of the map, and the lowest point of this will be a low area such as a sewer or a cave. So here we have a screenshot of how it sounds, and a video of the wind elevation. Now you'll notice the RTPC that I'm highlighting there. If I move it up, the higher that is, to 1300 meters for an example at this particular point, the wind is very, very different to how it sounds if I'm down in the basement area. Now you notice it's a different kind of wind, it's a different sound, it sounds different. This might be in a cave or a sewer area, and you would have other ambient sounds in there that you can add on top of it. But this is all based on the player, and it happens in real time. So that's a really good example of how we look into that. We can use that same information for any sound. So in this particular example, what if we had trees in the game, and some of the trees are at the top of a high hill and some are at the bottom of the hill, but at the moment we don't know where these trees will be or if these trees will be placed halfway. We can use the wind strength and the player elevation to affect the tree movement. That way we only have to add in the tree movement sounds to the trees, and it will automatically be changed based on the player's elevation and the current wind strength. So we don't have to do anything. That just works straight out the box. It doesn't matter where we put that tree. The wind sound is triggered by where the player is rather than where the actual sound object is placed. And that's a good thing, because it doesn't matter if they change the elevation or they change anything. It's all scalable. We get it for free. So here's a good example with the tree movement sounds. So here we start with calm trees. And we're going to move the tree movement, which goes from calm to strong movements. Now you'll notice that we can move this up and down from like small ambient to really harsh, heavy, strong tree movement sounds. And then we can move back down again. So this is a really good example of how we can use the wind strength. We can hook that wind strength or the player elevation directly into the tree movement, and we can use those same numbers. We can also use the output of one sound to adjust the RTPC of another. What if the player is stood in the middle of a forest? It is calm, but a one-shot gust of wind, which randomly plays anywhere in the game world, it's a random one-shot sound just like the bird song, plays near the player. The gust of wind sound should affect the tree movement, but we don't know when or where the gust of wind will hit. Now, realistically, typically, we would have a code solution for this, but this is a prototype, or this is a very early stage of the game development. We don't have code support at this point, so we have to be improvising. We can use the RMS output, which is the green sort of lines that you see on the output gauge, which you'll see in a minute. We can use those numbers to adjust the RTPC of the tree movement. This allows the trees to move with the sound of wind. So in this particular example, I'm going to show you what the sound of the wind gust sounds like. So when this wind gust is here, you'll notice the green bars of the volume. Now that goes from -60 to 0, 0 being the normal thing. We can then use that output to adjust the tree movement RTPC, which we was adjusting earlier. So if we play the sound of the wind movement again, we notice that the bars here, those are flickering up and down. They go from like -60 to 0 is the actual parameter set on the tree movement. So if we play the tree sound, which also has the wind gust, you'll notice that the tree movement sound is affected by the volume of the wind gust. And this is perfect because it's based on the output of the sound, based on what the player can hear. So if the player isn't anywhere near that sound, that RMS level for the player is non-existent, therefore the trees don't move. So if the player is in the middle of a forest and the trees are playing a sound, and the player hears the wind sound, depending on how loud he hears it, depends on how much that affects the tree, because it's based on the output of the sound, based on what the listener can hear. So far, we haven't really needed to talk to a programmer or a designer for help. Now, this is all done from one blueprint by the audio designer. There's no code support at this stage, nor is there support of implementation from a designer. This blueprint can be applied to any or all of the levels in your games, but you might have to adjust the ambient zones for the level. But the logic will work straight out of the box. Now, the real question here is, what's the point? Why would we do that? Well, firstly, it immediately adds character to your game, or it gives the game life. And so far, it's only taken your audio designer about 4 or 5 days to get this stage in the development process. It immediately adds something to it, but it also gives the audio designer an opportunity to go to the technical director or the design director and say, this is the kind of thing that I want to be able to do. Can I have some code support to make this more streamlined and make it a little bit better and hopefully find everything that we need? So why bother at all with any of this? Like, building an environment that feels alive and believable can influence the player in a significant way, and it doesn't take much to do this. If you have someone who knows what they're doing and has the agency to crack on and do it, it can sound excellent. The skills and ideas presented in this video can be applied to every aspect of the game's audio, not just the ambience. And all the ideas and skills presented so far can be done in a much better, more specific and finer detail for the final product. But you need to know the scale and the scope of what the audio team need. This is a great way to find that out. Here's a video of everything that I've just discussed so far being used in the game environment. The visual content is from the Unreal Open World Demo Collection, which is free to download, and all the audio content used has been what's been discussed in this video so far, from the rain to the wind to the trees to the animals. This is an ambient zone. Now I've added a spawning like sphere over the sound so that you can visually see those when they are actually spawned. You can actually see them being spawned, but realistically when the game ships, the sounds will be invisible. This is purely so that you can see what it looks like in the game world as it's being spawned. And the large sphere that are around it, that is the roll-off, so that's how far away the distance attenuation is for each of the things that are spawned, so you have distance there. In this example, you can see the wind and the trees being used a little bit more advantageous, and eventually you will hear the use of the bacon frying as the rain and the introduction of a thunderstorm. The thunderstorm we've not touched upon in the video, but it's just a standard sound of a thunderclap. So it's nothing special that we're doing there. We just randomly play that again, randomly every 5-10 seconds sort of thing. But if we wanted to, we could move that storm. We could give it a starting point and an end point, and we could say, move this sound over the map over the course of 35 seconds so that it sounds like to the player that the storm is actually moving overhead. That's a very clever way of actually sort of making the player feel like they're actually inside the game world and things are actually happening around them. Again, we can do that in the audio blueprint. We don't have to touch code support for that. We can just trigger it. Though you might want to talk to your technical designers and your tech guys to worry about the visual effects for thunderstorms. They are not cheap. Thank you very much. I am now open for questions. I'll be on the chat at some point, I think. Thank you very much for your time, and I hope this has been instructional and informative. Thank you very much, and good night.
Yeah. Well, let's pin you then. Great. Thank you so much. Now I want to remind the chat that you can just ask your questions there, and Rob will go ahead and answer them. So even like right now as we're talking. So Rob, go ahead.
Okay, so I'm just going to field a couple of questions that I've already spied in the chat. One of the main ones that's coming up is why use Wwise when Unreal has insane support for audio features and integration to the blueprint layer that allows better and faster iteration time and collaboration with other disciplines? Is it just a fear of change because it's how it's been done for years, or that using U audio requires blueprint and Unreal knowledge, which not every audio designer has? And a common theme for that is when people are using, like, why not use sound cues that are in Unreal? Personally, I have no difference. It makes no difference to me which one I use. Wwise is fairly sort of industry standard for AAA sort of stuff, or other sort of middleware like Fmod. From my perspective, at least for my current project, it is purely and simply because of having the ability to hit the ground running. The project was already up and running with Wwise integrated into it. It was already being run with all these sort of infrastructure behind it. So it was a case of being able to jump in and be able to hit the ground running. I have worked on other projects using just Unreal Audio. I would love to sort of use Unreal's latest sort of audio. Yeah, at the moment, like with their latest release of 4.25, they have some insanely cool stuff. The problem with that, of course, is up until 4.25, it was all in beta. It was all basically a test platform. So yes, that was available to us. Yes, we could use it, but it's ultimately it wasn't. It was always in a beta sort of stage. You couldn't really sort of, it wasn't recommended that you sort of do any significant sort of work on it until they officially released it, which was 4.25, which I believe is this week at some point. The other side of that coin, of course, is with anything that's new that's come out, yes, they've got some excellent stuff. They've got some really good solid funding, some facilities that are there, but it's learning what it is. How does it work? What does it do? What's the functionality? And that might be time that you simply don't have in your current workflow. Like for us at the moment, with where I'm working at the moment and the project that I'm working on, time is very, very much a commodity which is in high demand. It's like time is running out. We have deadlines coming up, and we need to be able to do fast iterations on the existing systems that we have. We don't have time to learn new methodologies, new technical things diving into Unreal. That said, in my spare time, that's absolutely one of the things that I will be doing now that it's been released and I can freely have a look at it and see what's going on. So hopefully that's fielded that question. When it comes down to using Wwise and sort of the rationality behind that is, if you are working for a company and you have a specific kind of budget, then introducing a middleware can be very beneficial, but it's not forced to be the right solution for your project. So as with everything like that, you've got to take it under advisement, not just as an audio designer, but also from a technical sort of standpoint as well. You know, like, what are the costing implications? What's the technical implications? Everything else that is associated with that. And then you've got to think about the bandwidth of sort of the support that you might need, and lots and lots of other sort of questions that you may or may not know the answers to. So that's one thing. Another question that was asked was, what would be the minimum requirements for an audio designer if they were just starting out for sound design? So the first thing that I would probably recommend is, as much as it pains me to say it, download free software called Audacity. That gives you an opportunity to add in any sound that you want and play around with it and edit it. So maybe start with editing your own music to, you know, as a sort of place to start, so you can understand how editing works and you can understand the implications of what it is that you do, and the reactions of what your sort of meddling, if you will, causes with the sounds that you're working on. Again, you could use Unreal. You can get Unreal sort of, it's free. There are numerous and bountiful videos online on how to use Unreal, tutorials on how to use blueprints, tutorials on how to implement sound, and how to be more technical or less technical than you need. That is a really good place to start for any aspiring sound designer. Is start at the very beginning. What do you want to do? How do you want to do it? Google it. It sounds like a bit of a get out of jail free card, but it is fairly sort of, it's, yeah, we live in a time where we have this information at our fingertips, and there are numerous sort of social media groups, there's numerous Twitter accounts, there's numerous YouTube channels which are designed at introducing game development and sound design to absolute beginners. Why, you know, everybody's on lockdown at the moment, everyone's got a lot of time on their hands, why not start doing exactly that? Now, to field one of the a part of one of the other questions, which I believe Nick asked, was if, you know, the implications of not knowing blueprint knowledge or Unreal knowledge, because not every sound designer has that information. That is true. Some sound designers, they only deal explicitly with sound. They don't deal with anything technical. They don't care. All they say is like, oh, this is the sound of a car, off you go. It's up to the designer or a scripter or a coder to implement that. I like messing around with Unreal. I've spent a few years just sort of learning different things, different ways of doing things. And it is by no means, as you can probably tell with some of the way that I've done certain things, almost everyone's going like, why are you not using that as a function? Or why are you not doing this? Why are you not doing that? Because it's a prototype. Like, my job is, like, in my head, I've got an idea as to how something should work. And because this is how I think it should work, or how I want it to work, it's easier for me to just literally open it up and go, right, I want to do this in this way. Like, you know, for the spawning of sounds in a zone, I did a Google search to find out how to do that on YouTube. And there was a guy who did a tutorial video on how to make soft plushy unicorn spawn from a plane. So I basically took his maths and went, this is the, like, there was a 3-minute section of a 20-minute video that I went, that's what I want. And I modified that for my own means. And then I can give that to a coder or a designer, and I say, this is what I want, this is how I want it to work. And they look at it and go, Jesus Christ, what is that mess? Oh, that's like 4 lines of code. Brilliant, off you go. It's like, my job is as an audio designer is to make it sound good, or at the very least to put people in a position where they can understand the importance of what it is that I do, and put them in a position where it's articulated in a way that everybody can understand. And all of this that I've just shown you now with just the general ambience, this is all done in the space of a week. Yes, it could be done a lot better. Yes, it can be streamlined. It can be much, much better. But it's the basic principle of it. And this is where we need to start explaining to people, well, if I have the infrastructure, this is what I want, this is what it adds to the project, they can schedule it in. we can get the code support that we might need to do a better, more concise, and much more optimized version of what it is that we're trying to achieve. That makes my life easier as an audio designer because I know I have the support, and it makes the game ultimately a lot better. Because whether you believe it or not, we can't shoehorn in 2 years worth of work in 3 weeks. No matter how many times you try and convince your production team that you can't. If you deal with this from the very beginning and you're always mindful of the fact that we might need this support later, and as long as it's scheduled in, 9 times out of 10, you'll have the support that you need, and you'll be able to do a much better, or at the very least, put yourself in a position where you can compromise and say, well, we can't have this, but we can give you support for that. And everybody wins from that perspective. I get to do at least most of what it is that I want to do, and the game will benefit from it. So, other questions? What have we got? Have we got any more? Yes, you could. Reaper would work, wouldn't it? Certainly not for beginners, though. Yes. Audio design or audio in general we're in a position where people have been using cassette recorders since the dawn of time, from like the 80s at least. But what it basically does is, if you wanted to record a song from the radio, you used to press record and play at the same time. And guess what? That's exactly how we record on Pro Tools now. You press record, you press play, and it records. The functionality of these softwares and hardwares and DAWs, they haven't changed. They work in exactly the same way. So it does effectively, it turns into a personal preference. Like, I could use Reaper. I've tried to use Reaper, but I prefer Pro Tools. So I stuck with Pro Tools. I could use Unreal Audio, and for future projects, if the bandwidth and the time allows, then I will use that. If that doesn't allow that and we need to use Wise, then I'll use Wise. If the bandwidth says, actually, no, we need to use Fmod, then I will use Fmod. It makes no difference to me what we use, as long as I get the right code support and I get the right kind of notice to do something, then I don't mind what I do or how I do it. The alternative to Wise, yes. Fmod is probably the most famous alternative to Wise. I'm sure there are some more, but for the life of me, I don't know what they are. We just tend to go with the known ones. Ableton, yes, yep. Not really used it in a sort of production environment. I've used it for sort of music production many years ago, but I don't know the integration levels of that now, and or how good it actually is. If that's what you've been using, then yeah, sure, go for it. Any more questions?
Okay. I think that's enough for now. Time for the next presentation. Thank you, Rob. And now we're going to switch over to Elodie's presentation about Iliad.
Iliad is a free plugin for Unreal Engine, and it is developed by Praxinos, which is a company I co-founded. The plugin is available since last December on the marketplace, but it's still in beta, so there is a big room for improvement, and any feedback are more than welcome. Today, I will show you things that have not been already covered in other videos, especially in the live stream we did for last Halloween with Epic Games. And for that purpose, I'll be using an asset from the marketplace, which will cover my needs for the demo. First of all, after you downloaded Iliad, make sure the plugin is enabled, because if it's not enabled, you won't access these options, Iliad and Odyssey Brush. Okay, let's create a new texture. Here we can decide the size of the canvas, and I give a name to that texture. Okay. If I double-click on the texture, I get the default viewer of Unreal Engine. This viewer is still useful as it gives you an access to some settings you can't find in Iliad. But if you want to open Iliad, you must do a right-click on the texture, Edit with Iliad. And there is the interface. We will probably add later a preference setting to decide whether we either want the Unreal Engine viewer or Iliad interface to open textures by default, but we don't exactly know how to, so again, any feedback is welcome about this. Okay, so as I said, we have Iliad interface. So we've got the canvas here. Here we have the layer stack. We have the color selector in this area. So you can use a color slider or a color wheel to change the color. At the top, you've got parameters like size, opacity, flow, blending modes, and alpha modes. At the bottom, we have options to rotate and to resize the canvas. And oops, I did not close the alpha mode. Okay. The option scale to fit is really nice because it scales the canvas to fit the size of the window. And at the left, there is a paint bucket that floods the current layer with the chosen color. And there is a bin to delete the content of the current layer. We also have options right there for the stroke, for the performances, and for the mesh, especially if you want to display the UV map of a specific asset. And at the top left corner, you can select your brush. By default, it might be empty. If it is, you just have to modify View options and click on Show Engine Content. The option Show Plugin Content must also be activated, but it's already the case by default. So there we have a batch of different brushes. So I will choose one brush and draw with that brush. But it's not very visible because of the background. So let's paint it white. And I add a new layer to use my crayon. Perfect. By the way, you've probably noticed that after choosing my brush, new content appeared right there. These areas dedicated to exposed parameters. Exposed parameters are parameters you decide to display in the blueprint of the brush. To open its blueprint, you can simply double-click on the brush thumbnail. And by the way, if some of you have never used Unreal Engine before, Blueprint is a visual scripting language using nodes. And so we based our brush engine on Blueprint to make it more natural to Unreal Engine users. So this blueprint is very simple. There is a node named Simple Stamp, whose you connect to other nodes to define colors, coordinates, information from a graphic tablet, etc. And here, the only parameter to be exposed is the texture used as a stamp. If you look at more complicated brushes like Cotton Bush, we can see that the brush is quite messy. I should really stop showing that one. But anyway, there are much more exposed parameters such as colors, the size of the leaf, and stuff. Okay, so what is the point of having a drawing plugin in Unreal Engine, you may ask? Basically, Iliad can be used to draw illustrations or graphic researches. If we go to our Discord server, there is a showcase channel where you can actually see a few examples. This drawing, for instance, is the first one ever made in Iliad. And that this is something I made recently to cheer me up during confinement. And you can also use Iliad to make sprites. So I did it with Iliad, and here you have an example of pixel art. You can also use Iliad to make tile sets and turn them into tile map thanks to native tools in Unreal Engine. And you can even use the plugin to make sprite animations. But as I said earlier, I won't cover topics like sprites or animations or tile sets or even the brushes, because I've already made videos that can be watched on our Praxinos YouTube channel. Today I'm going to cover topics that are not already on video. The first topic to be seen today is how to work with decals. Decals are very handy when you need to customize a surface like a wall. So first, I'm going to add a decal in the scene, right there. I will give a name to that decal. And then I will rotate. So now I will create a material based on the texture I created earlier. I open it. I need to change the material domain and the blend mode, because as it is a decal, it has not the same way of functioning. I apply,
and I drag and drop the material into the decal material. Now I want to show you what is of the most interesting part of Iliad. But to do so, I have to resize my window, and then I edit texture with Iliad. Great. So we can see we have the texture displayed on the wall. Perfect. But let's imagine now I would like to have something transparent. To do so, I just have to disable the white background. I will click on the eye, and it's not exactly transparent. We see a black background instead of the white. And that's because I have to change a parameter in my material. I actually have to connect the alpha channel to the opacity. I apply, and now you can see it is transparent. The green stroke is now transparent. But let's do something more interesting. So I will delete the content of that layer, and you'll notice that it updates immediately the decal on the wall. And if I take another brush, I change the color and I try to draw something, you can see it updates the decal. That's one of the most interesting part of Iliad, is the fact that anything you do on the texture, as long as it is used in a material and it's applied on a surface or on an asset, it updates texture in real time. I have to rotate the shape again because it's upside down. And let's have some fun. You can see I can paint. I can even make some drops, like if the painting has drooled on the surface like this. I can even play on the opacity if I need it to be more transparent. And basically you understand how decals work. I can show you better examples, and so I will show you things I have made earlier. So I select my decal, I drag and drop this material, and I will edit the texture linked to the material. And you notice there are much more layers in that texture. We even have folders. That's something I really want to underline, because if some of you have already used Iliad previously, the first version couldn't save layers in the texture, and now it is possible. So yeah, kudos to the development team for that. So yeah, I'm playing with the layers so you can see how it updates the texture in real time. And we can even play with the blending modes, the layers blending modes. If I change here from multiply to normal or to screen, for instance, you can see how it changes the rendering of the layer on the decal directly. Okay, now let's play with something else. Foliage, or foliage, I don't know how it is pronounced. Foliage are used in Unreal Engine to paint with meshes. For instance, if you want to create a forest and you have meshes of trees, you can use the foliage to create many trees and make a whole forest. It's very handy as a feature. First of all, I need a mesh, and so I'll be using one of the very basic shapes included by default in Unreal Engine. So I will take a plane, I drag and drop it into my content browser, and now I have to go to the foliage tab at the top to drag and drop that plane as a foliage type. Now I'll open the mesh, and then I drag and drop my material to replace the default material. So the idea is to use the foliage to paint a climbing plant on the wall. To do so, I need first to edit a few things in my foliage parameters. First, I increase the Z offset, because if I don't, the foliage will flicker because the mesh is a flat plane. So I need to change the offset to avoid any flicker, right? Then I will also change the ground slope in order to be able to paint on the wall, because by default you can only paint on a rather flat ground. And now I paint with my foliage. You see how fun it is. Okay, that's lame, sorry. Let's change our texture and do an actual plant, okay? So I go back to the texture and I kill the fun. And I will use a different brush. I will use camouflage, which is a brush made of an array of various stamps of various patterns, and that use various greenish colors. So I modified the texture, and we can see it changed the foliage in real time. But I'm not very convinced by the results. That's because I forgot to change the material parameters. So I go back to the material and I change the material domain from decal to surface, because it's not a decal anymore, right? I'm not very convinced by the results. I will use another brush. I will use Cartoon Bush again, like this. I don't really like the results, so we'll maybe add more foliage. So we'll change the density. So the density will actually add more meshes at the same time when you paint with a brush. But I don't really like the results. Okay, so I will go back to camouflage, but this time I won't paint with camouflage. I will turn it into an eraser, and to do so, I have to change the alpha mode from normal to erase, which will make something more leafy. I don't know if it's an actual adjective, but there's just something wrong with that because I forgot to apply the material parameters. Yes, that's much better. Now it is not a decal anymore, it is a surface. Yeah, we can see it acts more like a true ivy, like a climbing plant. Let's turn a little around the building so we can see we can also paint on the other side of the building. And because I am a true cliché of a girl, I really love flowers and I do love pink, so I will add pinky flowers. I will use a simple crayon and I will pick a pink and draw little pinky blobs. We can't really see the result. I don't know if you can see on the video. Let's maybe zoom in so you can enjoy my art. Yeah, you can see the pinky dots. Now I'm about to show you how we can also use Iliad for post-process renderings. Unreal Engine offers many incredible tools for post-processing. I don't even know like 5% of it, but I hope I can at least give you a good glimpse of it through Iliad. So I will add a post-process volume in my scene. I drag and drop it in my scene. I give it a name. And I will immediately configure something in the post process. I will check an option to unbound the post process, which means it will always be visible regardless of my position in the scene. And now I'm going to create a new texture again and add a new material from that texture. Then I double click to open the material. First of all, I have to change the material domain from surface to post process. Then I have to create a new node named Scene Texture. There it is. And I will connect Scene Texture to the texture sample thanks to another node named Add. So I connect color to A and RGBA to B, and I connect it to emissive color. And I forgot to change a parameter into Scene Texture, so I click on Scene Texture and I change the ID to post process input. I apply, then I will open the texture, resize my windows so we can see both at the same time. and I will make a few brush tests. So I add a white background because it will be necessary, and I create a new layer, and I will look for a good brush for my tests. So I'll make it a little bigger. I'll change the colors. And yep, I can paint with it. That's perfect. And now, obviously, I have to use my material into my post-process volume because it is not the case yet. So I have to find it. It is into rendering features into post-process material. You can actually add an array of materials, but for that example, I will just use my single material. I drag and drop it, and now you can see the results, which is quite interesting. And like for the decals and the foliage, if I edit the texture, it edits the post-process. And because I have checked the unbound feature, when I turn the camera, we can still see the result, the texture, just like if it was a mask or a stencil. Let's have another result. So this time I won't be using add node, but I will be using multiply. So I add multiply. I connect it like this. I apply. Never forget to apply. And there we have something totally different. Instead of having a stencil, we are using the texture as if it was a stain on the camera view. And we can do something even funnier. Let's imagine, for instance, I would like to use the texture to act like kind of fog. So I can add a new node named Panner, like this. And in the details of Panner, you can change the speed of X and Y axis. And the Panner will actually move the texture depending on the value entered in the details. We apply, and there we have that result. This example will be actually very handy because I can then show you something. The fact that by default, if you use any brush, you will have this, seam, you have this border visible on the texture, which is not what you want. If you want to have something that if you want a looping texture or a seamless texture, you can do that by changing the parameter of your brush. To do so, you have to open the blueprint of the brush and open the class detail just by clicking here on that icon. And by default in Iliad, we offered a new class that is the looping class. So you just have to change it right there. And when you use the looping class, you will be able to use the brush to paint in loop on your texture. So you will create seamless texture. And because now I'm using the looping class, I have the possibility to find a new node named Odyssey Looping Stamp, which will connect to the other nodes. So particularly, I'm just connecting, the sample, the pivot, the X and Y coordinates, and the pressure tablet to the flow. I delete the simple stamp because I don't need it anymore. I check tile horizontally and vertically, and I compile my blueprint. And now if I paint with my brush, I can paint seamlessly, because if I go to the left, I paint to the right, and if I go down, it paints at the top. And you can see on the left, on Unreal Engine viewport, there's no seams anymore. There's no border on the texture. I can show you another result with another brush that was already configured to be seamless. And just like other textures, I can also play with the opacity to have something more subtle. Now it looks like a true post-apocalyptic environment. Or maybe a post-COVID-19 environment. Who knows? Last but not least, I wanted to show you quickly how you can also use Iliad to edit actual assets like 3D characters. So to do so, I'll be using animals from Unreal Engine Marketplace. And I will start with this deer. I will open its mesh. We can even see I actually already played with him because these marks were not on the deer at the beginning. I added these scratches on his skin. So I will open the texture and just move the window so we can see both the mesh and the texture at the same time. So we have a couple of layers, a layer with a white neck and the scratches, and here we have some fur, which is the original texture from the marketplace, from the deer. So I add a new layer. I will use this brush, which is another brush included by default, to be used to make scratches. It's a blood brush. And you can see the results. And what's interesting is the fact that even if you decide to display the animations of a character, you can see the results in real time. So if I keep editing the texture of the deer, we can see various changes. I'm sorry, sometimes it can be quite slow. It is because my MacBook is not as powerful as a true desktop. And I'm running a recorder in addition of Unreal Engine. So yeah, sorry for the slowness. But here you can see the result. Okay, so another type of example was with an animal. And this time I'll be using a crow. So I open the mesh. We'll look for an animation. So here it is. No, that's not the one I want. Fly, please. Better. And like for the deer, I open the texture. Drag and drop it on another window. Yep. And this time I won't just create a new layer, I will duplicate the existing layer. Thanks to that, I can lock the alpha channel, which means I will only draw on the existing pixels. I took the airbrush, I took a fancy color, so you can see in real time what's happening on the crow. Again, it's a little bit slow, but you can understand the thing. And here what is actually interesting is not the fact that we are painting blue the crow. It's the fact that you can also use that color to combine it with another blending mode like soft light, and which will be useful to make different characters very easily just by changing the colors. If you need to make, I don't know, shiny Pokemon-like creatures, it can be very easy to do thanks to Iliad. And yeah, so that's all. I really hope you like the demo, and if you have many questions, feel free to ask. I'm here for that.
All right, thank you very much. I guess now Elodie will be taking all your questions. Remember to write them in the chat below if you have any. And Elodie, I'll let you take over.
Sure. So one of the first questions was, is it a Finnish accent? So definitely not. It's not a Finnish accent. It's a French accent. But thank you. Sounds like my pronunciation is not that bad because you can't guess I'm a French. Okay, now real questions. One of the questions was, is it macOS? And the answer is yes, it is macOS. You may actually wonder why I'm using macOS and not Windows. First of all, because I actually like this kind of computers. The second reason, less selfish, is the fact that many artists actually use Mac and not Windows, or actually they are like 50% of Mac OS users and Windows users. And we want to build solutions for artists, so it makes sense that we do something that works for both Windows and Mac users. One of the other question was, is this the live version of Iliad? I'm not sure. I'm not quite sure I understand the question. I think is it the current version available on the marketplace? And the answer is yes, it is. And but please take note that since for the version 4.25 of Unreal Engine was released yesterday, there's no Iliad version yet for this version. The last version available on the marketplace is for 4.24. There was so most of the questions were actually answered by my colleague Galandil, which is his real name is Thomas. So thank you, Thomas, for all these answers. I will add a few things that have been forgotten, maybe. Can we play with height map? So in theory, yes, you can. As long as you work on textures, you can work on Iliad. So that's not something I have tested, or none of us had tested that actually, but it sounds feasible. So maybe for the next meetup, I'll be happy to make a test and tell you definitely if it's possible or not. There was a question about the ratio. When you create the texture, you can choose the ratio of the texture, and I advise you to go for a multiple of 2 for the textures, because to avoid any bitmaps issues later. But then when the texture is created, you can't resize either the texture or change that. You are limited to the size of the texture you've chosen at the beginning. It's something, as Thomas said, is something we hope to bring in the future, having resizing tools, but it's not the case at the moment. However, there's something interesting to highlight, is the fact that when you create brushes, Odyssey brushes, you have the possibility to resize the texture of the brush, and you can either resize the texture uniform. You can, the resize is uniform, sorry. Or you can decide how the resize will be. You can then create variables to say, I will change the size horizontally or vertically. That's something you can do through the nodes. But it's only when making a brush, not as the texture, the canvas itself. I think, do we have other questions? What do you mean about drivers? Oh, I think I'm missing something. I think I'm missing something about drivers, so I don't know what's the issue. If the issue is, what about the drivers between Wacom and Ink and Microsoft tablets, for instance? For Windows, we are compatible with both API, so you can either use a Microsoft and Ink tablet using Ink API, or the WinTab API for Wacom tablets most of the time. And on Mac, well, that's the same actually. You can't change if you what is the API to use, but it's it works both with Wacom tablets and any other types of tablets. As long, I mean, any tablets so far we tested could work with Iliad, so it's good. And I think, yeah, that's all for the questions. Yeah, I think that's all. Just a little things. I would like to thank a lot the Unreal Engine French community, because they helped me a lot for the making of this video. They gave me a few tips because I am quite a beginner with Unreal Engine, and so this video went very good thanks to them. So kudos to the Unreal Engine French community.
Right, great, thank you. Now, what I'm going to do is that I'm going to switch all of us to be able to... There we go. So now we can spend the last few minutes going through any questions anyone has for any of us. So if you have any questions for the Unreal modules or the audio or Iliad, then go ahead and put them into the chat right now.
I see there is a question right now. Can the texture created with this opened in any other program? So what's the format? Well, we are limited to what Unreal Engine can do. So either you can export the texture in TGA or in bitmap. And I think there is also a plugin, a free plugin that makes possible to export in PNG. And in that case, then you can open these textures in any other painting software like Photoshop or Krita, for instance.
Tough crowd.
Yeah, and Rob, you were asking, answering a few questions there on the chat. Is there anything that you want to repeat on stream for the ones looking at this after the stream, because they won't be able to see the chat?
Okay. Yeah, someone was asking about sort of what hardware I use when it comes down to sourcing audio. Personally, it depends on your budget. Sort of at Redhill, we use a Zoom L12, which is like it's an 8-channel mixing desk, which is also USB interface. So you can use it as an audio interface with Reaper or Pro Tools or whatever sort of program you prefer, Ableton, things like that. And you can also use it as an external SD recorder as well. So you can take it on location and you can record up to 8 tracks at the same time and record pretty much whatever you want, as long as you've got the relevant sized SD card. Then you can just stick it in the back, record, jobs are good, and then you can use it as an SD card reader. So you just connect it USB to your PC, click and drag the files, voila, job done. So yes, there's that one. And someone's just said, how long have you been in development? Who?
Well, all of us.
All
I
of
can
us.
start. Well, I've been in development for, I think, around 12 years. I started with web games in Flash, and then I went to mobile games, and now I'm doing big screen games like console and PC.
For me, I've never been into development myself because I'm not a developer. I'm a sales agent, CEO, secretary. I do many stuff, but I'm not a developer. But for Iliad development, there is a cat behind you, Eddie. For the development, Iliad is something our team is working on for a year.
I've been in audio production now for a long time, over 20 years for audio production. For video games, I started way back in 2008, and I've been pretty much doing video games ever since. Did a couple of things down at Pinewood Studios, but yeah, I've been mostly doing sort of video games and audio since 2008, which is a very, very long time when I sit and think about it. So yes.
And I guess Iliad has been
someone...
in development a little more than a year.
I see in the questions in the chat they're asking if we are Nancy or a mess. So little thing about that, because in my town is supposed to be pronounced mess, but it's so awkward to say in English we live in a mess. Anyway, so we are from Mess.
I'm not saying anything about England right now.
Yeah. I guess that's all for the questions, unless... Yeah, nothing. But yeah, otherwise I think this went really well.
Yeah.
Thank you to Ari for setting this all up, and thank you for everybody for watching. It's been really, really good.
Yes, thanks everyone who joined.
Devastating on my first time twitching as I was expecting. And
thank you, of course, Rob and Elodie for presenting and answering and being here. It's been great.
Thank you very much for the invitation.
Thank you for having us.
At least I had a good occasion to wear something else than sweatpants.
Yes, I put on pants just for this. Otherwise, I've been wearing pajamas for weeks now. So thanks for the excuse. I really needed it.
There's a reason the camera's set here, so...
Yeah. So let's call it a stream then. Thanks, everyone. Bye-bye.
Thank you. Bye.
Bye-bye.